So the unit circle, we have a terminal side which is xy. I have this link here, but it actually just goes right to this. So, right, we have x squared. This is my unit circle. You see a radius of 1, right, 1, 1. So the terminal side, right, where this ends, this is a good visual because it gives you the coordinates right here. Now this is measured in degrees. It could be radians, but the coordinates would be the same. So think of the unit circle, which is x squared plus y squared equals 1, right? Remember, 1 is like r squared, so radius. And then we have x squared plus y squared. So that gives us a circle, but these all, wherever this angle, wherever this point, the end point of the radius ends up, has a specific coordinate that's associated with it, right? So 0.63, 0.77, right? That's the coordinate of it. So when we think about what we're doing today, which is sine and cosine, I want you guys to kind of remember from geometry, well, sine was like so. We did sine, cosine, tangent as so, ca, and then toa. Now, we don't really need to worry about tangent today. That's going to be the next unit, or the next lesson, which won't be for a while. But sine and cosine we do want to know. So sine was so OH just meant opposite over hypotenuse. And cosine was ca, adjacent over hypotenuse. So really, opposite and adjacent is the only thing that's different. They're both over the hypotenuse. Well, we can think of sine of theta as y over r, and cosine of theta as x over r. So how does that really work? Well, basically, if you think about each, you can see a triangle that's formed right by here. So this is theta in here. This is the angle that we're worried about. So sine of the angle would be basically opposite, which would be right here, over hypotenuse right here. So sine is going to be basically this opposite corresponds with the y coordinate, right? It's how far the graph is going up. Even if I move it over to this side, right? This is going to be theta in here now. Don't worry about this green one in here. But sine of this angle is going to be opposite over hypotenuse, right? We're always going to be creating a right angle in here. So that's why I said don't worry about this one because there's no right angle here. The triangle that we want is this one right here. And if I move down here, right, this is the triangle we want. I have my right angle, sine of basically just this angle, right, just using the x-axis as one boundary, and this line is the other one. So hypotenuse, opposite, adjacent. And if I move it over another one, right, I still want to use my x-axis and this one. So now I'm looking for the sine of everything but the green, basically. Opposite over hypotenuse would be sine, and then cosine would be adjacent, so this one over the hypotenuse. So I'll put it back into quadrant 1. Keep in mind quadrant 1, quadrant 2, quadrant 3, quadrant 4. But we'll just keep it right here. So sine is going to be the opposite over hypotenuse. Well, and then cosine adjacent over hypotenuse. And you always want to work with this right angle in here. So what you see is this slide here, which is sine of angle for the unit circle only, right? We're going to get to somewhere it's not the unit circle, but for the unit circle only, sine of theta is just y, right? And cosine of theta is just x. Well, why does that happen? Well, because if you look at this, the hypotenuse right here, always a right angle, the hypotenuse is always going to be the radius, right? The radius going to the inner circle. And the radius in the unit circle is always 1, right? It doesn't matter where I put this, the radius is always 1. That's what makes the unit circle so special. So when you think about sine of this angle, it's opposite over hypotenuse, but the hypotenuse is 1. So really, anything over 1 is just itself. So sine of this angle theta is just going to be whatever the y is. So sine of this angle is just going to be 0.87, right? I don't really care about the 0.5 for sine. I'm only concerned with the y coordinate for sine within the unit circle, right? This one here, sine of this angle in here is going to be opposite over hypotenuse. Well, the hypotenuse is still 1, but opposite is the y, so that's going to be 0.81, right? Now, can I go back here? Cosine is adjacent, so the x-coordinate, right, the distance from here to here, over hypotenuse. Well, the hypotenuse is still 1 because the radius is still 1. So the cosine of 44.38 in my unit circle, is just going to be 0.71 because that's the distance on the x, just 0.71. All right, if I think about moving it over here, the cosine, I just want this angle in here, just with the x-axis, but the cosine of this angle is just going to be, right, adjacent here over hypotenuse, which is 1. So the cosine here is just going to be, oh gosh, can't even read that, but it looked like it was, maybe 0.7. Yeah, negative 0.7. That's what it would be. So sine corresponds with the y-coordinate because the opposite is how far it goes up. And cosine corresponds with the x-coordinate because that's the adjacent side of how far it goes across. So you want to make sure you get those definitely memorized. But it only works for the unit circle here because the radius is 1.